Hello, welcome everyone. In this question it says 2500 kilogram car traveling to the north, so positive direction, is slowed down uniformly from an initial velocity 20 meter per second by the force of 6250 braking force acting opposite direction car's motion. Use the impulse momentum theorem, answer the following questions. At the A it says, what is the car velocity after 2.5 seconds? So first of all, mass of the car 2500 kilogram and initial velocity 20 meter per second. What is the direction of it? North, so it is positive. And the force here, it is given 6250, but that force will be negative because it's acting opposite direction. So at the A, it says, what is the car's velocity after 2.5 seconds? So due to momentum and pulse theorem, F times delta t equal m times v final minus m times v initial. And it's asking final velocity. So if we send this one to here, and if we divide by both sides to m, v final will be f times delta t plus m times v initial over m. So v final gonna be f is negative 6250 times delta t is given in the A 2.5 parenthesis plus mass of it 2500 times initial velocity is 20 over m is again 2500. So the result will be 14 meter per second. So to the north it will be. And at the B it says, how far does the car move during the 2.5 seconds? So we have to use kinematics equations. X equal half v initial plus v final times t. So if we substitute the value half, initial is 20 plus final is, as we calculate, 14 times 2.5. So result will be 42 meter to the north again. At the C, it says, how long does it take the car to come complete stop? Complete stop means final velocity of the car is gonna be 0. So from the momentum in pulse theorem, F times delta t equal delta p, and delta t equal delta p over f, yani m times v final minus m times v initial over f. And the final velocity will be 0 because it says complete stop. So 0 minus m is 2500 times initial velocity is 20 over f is negative 6250. So result will be 8 seconds. And the time can be only positive. Thanks for listening.